Right, I think we can get started. Well, good morning, ladies and gentlemen. Welcome to this webinar, which is actually sponsored by the EOSC, the European Open Science Cloud, the Nordic, EOSC-Nordic to be precise. My name is Bert Meerman, and I'm from the GoFair Foundation. And it's my pleasure to be your host for the next 2 hours or so. Before we start, a few house rules. First of all, make sure that your microphone is muted, most of the time at least, to avoid background noise. Feel free to ask questions, but we would like to see that you use the chat for that, so we can pile up the questions and address them at a separate Q&A session after the break. Be also reminded that this session is recorded, and also be reminded that the slides are saved, and you can access them through the registration page. So this gives you also the opportunity to check the slides at a later stage if convenient. Right, let's talk about the program itself. As many of you know, we're involved in the EOSC-Nordic project, whereby we started to evaluate the fairness, so to speak, of the metadata and data published by the different repositories in the Nordic and in the Baltic countries. Okay, I'm going to try to change my slides. Yeah. Now, as many of you know, I would say, you know, I'm sure that many of you have seen this before, but still, I wanted to show one slide in terms of FAIR. The term FAIR is actually defined here as findable, accessible, interoperable, and reusable. And it relates to those 15 principles that you see on the slide here that data and metadata should adhere to. And not only for the human eye, but mainly for machines. And the machine or an algorithm should be capable to find, access, interpret, and reuse the data and metadata of a repository. And let me repeat that. The machine or an algorithm should be capable to find, access, interpret, and reuse the data and the metadata. So, as I said, I'm not going into great detail, but if some of you are not familiar with those FAIR principles, take time to study this in more detail. We all feel that FAIR is an excellent model to increase the interoperability, particularly for researchers. Now, there's a lot to say about FAIR, but let me make at this moment only one remark, and that is that FAIR is not the same as open and free. And I say that simply because we always get a lot of questions on this. The letter A in the word FAIR stands for accessible under predefined conditions. So making your data fair does not necessarily mean for a researcher that you have to give all your data away for free. Good. Let me say a few words about the assessment process. As you can see on this slide, we already organized a number of workshops and webinars on the process itself. As you recall, more than a year ago, we started with an initial assessment hackathon, whereby we gave you a number of recommendations. And also based on the outcomes of the hackathon, we organized a number of webinars. We did step 1, which was trying to help you to have the right unique resolvable identifier in place. We had step 2, where we talked about having the split between the metadata and the data and linking them with kind of a permalink, and so that they always point at each other. And just before the summer, we had step number 3, where we discussed how to use the generic metadata standards. Now, all these sessions gave you insights and recommendations for the repositories to improve the fairness in a kind of a step-by-step process. And take into account also that all these sessions were recorded and can still be found via the different registration pages. You may also want to read the FAIR adoption article from our team on the assessment process. We wrote this article in close cooperation with another EOSC project called FAIR is Fair. Some of you may know that project. And you see the link to that article at the bottom of this slide. Now, for this morning, we want to concentrate on the next step in the process, which is basically step 4, the domain-specific metadata. Domain-specific metadata. How does one define these metadata elements? What is the process to design, to define, to agree, to document, and finally to publish those domain-specific metadata elements, either for a team of researchers or for a, let's say, a team of professionals involved in a data exchange project, where you exchange data with several other parties. Now, in helping you, we thought it best to give the word to the experts who have gone through that process of defining these metadata elements for their community and who know how to get there in a number of steps. So that brings me to the agenda, and I'm very happy to say that we have some very distinguished speakers this morning again. After my intro, we'll start with Andreas Janssen. He is from Nijk, and he will be giving us an overview of the FAIR assessment project so far, of all these repositories in the Nordic and in the Baltic countries. Then we have Barbara Magana from the Environmental Institute in Austria, and she will be explaining what specific metadata was defined in the COVID research project for a large funder. I'm sure that she will talk about these M4Ms, the metadata for machine workshops, who actually helped her to define the right metadata. After that, we'll have Aniek van Arkel from the Purple Polar Bears in the Netherlands with a view and a video on an entirely different project. This project is related to the metadata required by the Ministry of Infrastructure and Water in the Netherlands. She's been working on sharing asset and planning data for a large number of data owners, infrastructure owners, in a country that is largely under sea level. So hopefully this project will be successful and keep us dry here in Holland. After Aniek's contribution, we'll have a short break. Depending on the time, it will be 10, 15 minutes or so. And after the break, we'll continue with Robert Huber from the University of Bremen in Germany, giving us insight in the specific metadata in the geoscience community. And then our final expert for this morning, Anna Maria Sempreviva from the TU, the Technical University in Denmark, with an explanation on what the wind energy community has done to derive metadata for their exchange project. And also here, I've seen that the M4M workshops have helped actually to shape the meta requirements for that team. So after all these experts, we'll have a Q&A session, which will be meditated by Josephine Nordling from CSC. And then I will come back to you, close the event with a call to action. So that's the program for this morning. Thank you very much for being with us. And without further ado, I would like to hand over the screen back to the next speaker, which is Andreas Janssen. Thank you very much so far.
Thank you, Bert. Just get my screen up here. Hopefully you see a single slide here. Okay, yes, so I should start by apologizing for those of you who have followed this series. I'm sure you have seen this presentation more or less multiple times now, but for those of you who are new, it may have some interest. So I'm the work package leader for the EOSC-Nordic work package 4 on FAIR data. So we're about 20 participants in this work package 4, and the EOSC-Nordic is a infra EOSC 5B regional implementation project, which started September 2019 and runs for 3 years. So we have a little less than a year left. So the approach that we took when we wrote the application was to divide the work in this work package into 3 segments, and the first one is the one I will focus on here today, which is measuring directly the FAIR uptake, and the second task was about implementation. So we have continuously been supporting communities in our region to implement both data standards and certification, Core Trust Seal to be specific. So we have a very strong team who are experts on Core Trust Seal and certification in general. And then the last task on policies and FAIR incentives. So this is a work that Josefina is leading, which will lead to a report on incentives based on interviews among various stakeholders in the region. So that is the work package as a whole, and I will focus on the first element, as I mentioned. So we from the very start, we had the idea to continuously measure, assess the maturity of our sample of data repositories. So the very first thing we did was to collect about 100 research data repositories in the Nordic and Baltic region, and then we have run an assessment process which is more or less fully automated using machine actionable metadata. So we're measuring the fairness of the individual data sets within 100 repositories approximately. So the very early and first result we obtained was that a lot of the repositories do not have identifiers, which precludes us from even measuring or assessing their fairness in this way. So that leaves about only 3/4 of the sample, which is then regularly measured. And we measure an average score of 24% in these about 75 repositories. So this is what this table looks like, and we have communicated this table to these communities and offered them feedback in terms of a guideline on how to verify or improve on those results, and also this series of workshops that we have here today. So these workshops have been an integral part of the service that we have offered to the communities, in addition to the results of the assessments. And the hope is, of course, that during the project that we will see an increase that we at least partially could associate with our efforts to support communities throughout this 2 or 3 year period of the program. So coming back to the assessments, we do not have a way to, or it is a very manual process still to collect data sets that we then go and measure the fairness of. So what we did was to take an approach that we randomly selected 10 data sets from each of the repositories, and then we measure those and take the average as an average fairness of the repository. So we've tested whether this approach is viable, and in 5 or 6 examples where we have a complete list of all data sets within the repository, this seems to match very well, in fact, as this figure shows. So this is what the current results look like. So this has been run using the Fuji assessment tool that Robert Huber will probably mention also in his talk today. So we have been using this for a year now, and yeah, the result is so apart from this red bar of repositories that we cannot even assess due to the fact that they lack global unique identifiers, we see that in this remaining 75 repositories, that the very large majority have quite a low score on these assessments. So of course, the tool doesn't measure every possible aspect, but there are about 14 or 15 metrics that are measured, and this is what we then define as fair. And of course, the machine actionability, which is also a requirement of FAIR, is built into that. So as I mentioned, 24 is the approximate average of this sample. And we have seen a steady increase of repositories sort of pushing towards the right end of this figure. So there are definitely things happening. And I should say that this slide shows the results using DataCite metadata also. So if we turn that option off, the average goes down to about 20%. So now we're measuring not using metadata from DataCite, which comes into the picture through the use of DOIs. So here we are measuring, let's say, the true or local fairness of the repository itself, which I guess gives a slightly more accurate picture of the state of FAIR uptake. So this was the situation a few weeks ago, and we have continuously measured this at least once every month since the beginning of this year at least. And this is one of the interesting aspects of doing these measurements continuously is to see how does this develop over time. So is it possible to detect small changes in, let's say, one repository makes an improvement in their FAIR support, then do we detect that? And it turns out that we in fact do so. There was a few repositories that actually made changes around end of August. And this turns up here in both of these graphs as a point which is somewhat above the trend. The challenge in doing these evolution analysis is that we also change the version. So the version of the software itself, the assessment tool, changes, and that obviously affects the results. But the red data points here, these are the results not using DataCite metadata, and they are quite stable. And there is what I would call at least a slightly significant signal in the last few measurements where things have started increasing. And I should also remind that this is an average over 75 or about 877 data sets from about 75 different repositories. So that is, in my view, it is definitely possible, and we definitely do detect changes in the FAIR uptake. And it is going in the right direction, but this will take time. So I mentioned earlier other things that we are doing: certifications, testing FAIR plus Core Trust Seal scheme by FAIR's FAIR, and conducting these interviews currently for the FAIR incentive study. And that is the last slide of my presentation with the highlights. So thank you very much.
Thank you very much, Andreas. In case you have any questions, please go ahead and put them into the chat, and we'll address all questions after all presentations. So there should be quite enough time for discussion towards the end. So I think we're just going to quickly move on to the next presenter. So the next person we'll hear from is Annick van Arkel. She is the co-founder of the Purple Polar Bear. The Purple Polar Bear helps with the design, implementation, and management of long-lasting FAIR data solutions. This is a recording. However, Annick is here in person, so she is able to answer questions towards the end if there will be anything from you that you wonder. So please start the recording. Annick, will you start the recording, or is it Bert at your end?
I thought I discussed beforehand that the organization would.
Yeah, I will do that. Sorry, I was prepared that Barbara was going to speak now.
Yeah, me too, but that's okay. Hi, we are the Purple Polar Bears. We help create scalable and industrial data collaborations by encouraging groups of organizations to securely and easily share their data with each other. We do this by implementing the FAIR data principles. However, this is based on quite a big implementation process. In this presentation, we will only focus on the metadata part of this process. So how do we implement these metadata files? Let's start with an example. We support a data collaboration that is called Working Together in the Substrate. The data collaboration Working Together in the Substrate started with 4 organizations. One of these organizations is the Municipality of Rotterdam. The Municipality of Rotterdam determined together with the other organizations which data they want to share with each other to work together more efficiently. Based on those decisions, the Municipality of Rotterdam want to share data about their assets in the substrate. We started with a small scope of data fields. In this case, we wanted to share the UUID of the asset, the name of the asset, the location of the asset, the material of the asset, and the diameter of the asset. An important condition of this data collaboration is that the data will be shared from the source. This means that the data will be shared from the server the Municipality of Rotterdam is currently using. This whole sharing process must be machine actionable without any interference of humans. But how are we going to do that? Because the 4 organizations that want to share data with each other all use different data formats, different semantics, and different standards. However, none of them is willing to change their internal data structure because this will take too much effort, too much time, and too much investment. This means we must fully interpret the data sources without changing them. We did that by applying the top layer approach, creating metadata for each data source to make it fully machine actionable. To do this, we created community-specific templates for sharing data in the substrate. To create metadata for the municipality of Rotterdam, we started with filling in the data plan template to create a data plan for their data source. Qualitative information about the data is documented with this template. Topics such as data quality, service quality, security conditions, and licenses are documented in the data plan of their data source. This is an example of a data plan template. We release those in JSON, which is a common data format. These templates are open source. We offer tooling to work on a data plan template with a group of people because often the questions within a data plan template are answered by different roles within an organization. After we filled in the data plan template, we move on to the metadata template. With this template, data formats, message definitions, data requests, data responses, and semantic links are made with the semantic web. In this template, we link with as many open standards as possible. This is an example of a metadata template. We release those in RDF, which is a common data format. These templates are open source. At this point, we gathered all the information to generate the data source specific metadata file. In this file, we incorporated many different topics, such as a unique identifier for the metadata file itself, that the underlying data conforms to an asset, under which license the data is published, which access rights are applicable, what time the metadata file is created, and when it was updated for the last time, and by whom it was published. The metadata also speaks about which coordinate system was used to communicate the location of the asset, who is functionally and technically responsible for the data within the municipality of Rotterdam. In addition to that, the metadata file makes other machines understand that if the data displays ME, that it speaks about some sort of metal. The machine understands metal because the metadata file links to open standards that describe metals and so on. So, just a quick recap. In order to fully interpret the data of the municipality of Rotterdam, we filled in a data plan template and we used a metadata template, after which we generated the data source specific metadata file. The created metadata file is evaluated by the community-specific FAIRification. This evaluator checks whether all the organizations within a data collaboration share the right data with each other, and whether they offer this in the right way. This mechanism therefore checks whether the metadata file indeed provides the correct interpretation of the data and whether FAIR and the community decisions and licenses are taken into account. If the evaluator gives a high enough score, the GoFair Foundation will certify the metadata file. At this point, the organization can provide proof to the members of the data collaboration that their data is indeed interoperable with the rest of the data sources shared within the data collaboration. Thank you for listening, and if there are any questions, please do not hesitate to ask them.
Okay, so apparently I mixed up the order there, but I think it should be fine in any case. So now we move on and we go to Barbara Magana, who was supposed to run right after Andreas. She is a data architect and semantic expert at Environmental Agency Austria at University of Twente. So please, Barbara, go ahead.
Yeah, thank you very much. Do you see one slide or do you
see presentation mode currently, so two slides. Yeah.
So this will be tricky because I'm using two screens. Okay, how can I do that? I will stop sharing and share again with only one screen. Hopefully this one. Still a presentation mode?
Yes, the same. If you go to the upper bar there, the second one, that in the middle there, you should be able to switch around.
It's that better?
Yeah, perfect.
Okay, thank you very much. So I'm very happy to present a work that has been done by me and to other colleagues the last 11 months, based on workshops called Metadata for Machines, to build together with a community, the COVID-19 community funded by the ZNMV funder, community-specific metadata. So this work has been led by Eric Schultes, the FAIR implementation lead of GoFair Foundation. And I helped and facilitated the process of creation of community vocabularies and templates. And my colleague Nikola Vasiljevich from the Technical University of Denmark designed the metadata templates at the dataset level and developed and provided FAIRification tools that supported the whole process. And so these slides really present the common work we did in the last 11 months. The community we served is the community of COVID-19 research that has been funded by the ZNMV, which is a Dutch fund of health research and innovation project. And the program under which this has been funded included a series of training events for involved project data stewards in applying FAIRification approaches to improve interoperability of metadata, but also data in collaboration with GoFair Foundation, with DTL and Health REI, and that's Dutch National Health Research Infrastructure, for optimal access to knowledge, data, but also samples. And the objective of this COVID-19 research community, together with Health RI, is to build a national COVID-19 observational and innovation portal with metadata from more than 130 funded projects, covering topics from healthcare to diagnostics, prognosis, immunology, and socioeconomic studies. So a very broad range of domains here under the umbrella of COVID-19. So we work together with 62 projects, but the portal will be used by over 130 funded projects. So here you see the traditional research cycle. Normally research applies for funding, submitting a proposal. The funder agency then selects the funds, the projects to be funded. Research starts and produces lots of intermediate results. At the end, data is then published or also stored in specific data repositories, and results are then also published in papers. This is what normally happens. But the problem is that the data on which the publications are grounded are mostly lost over the time, because the data repository are typically not fair, not findable, accessible, interoperable, and reusable, and very often also not after some time, no more reproducible by the researcher themselves if they don't care about their metadata. So what is needed to be done? We have to make data fair, and as already heard, a good guide for that are the 15 FAIR principles, which are based on a publication from 2016 from Dickinson et al. And this is quite a good starting point, but there is quite also a big interpretation challenge what this means in the real how to really put this in practice. But we can already see that mostly FAIR is about providing metadata, and this metadata should be machine readable and more and better also machine actionable metadata, so interpretable by machines, how to use the data and what this data is able to link to, and to how this data can be served by different services. And therefore, if we are able to provide machine actionable metadata, we can already achieve 90% of the FAIR score, more or less. And so metadata can be provided at the generic level, so using open standards, but it is also important to provide domain-specific and community-specific standards that are agreed within the community of the research, and in our case, it's the COVID-19 research community. So with the metadata for machine workshops, we hired domain experts to provide a metadata standard which is machine actionable. And machine actionable means that we build on the linked data approach, which helps to be interpreted by machines. And the JSON LD is also a good choice because it is an ideal data format for programming environments, REST web services. And we really provide this metadata with in linked data and JSON LD formats. And in addition, the metadata schema that we developed together with the community must be using, or the metadata provided within the metadata schema should use vocabulary, a fair vocabulary, that so that at the end you have really fair metadata. So the answers or the options to choose from when filling out the metadata should reuse vocabulary. And for both, for the metadata schema and vocabulary, we use tools like the CEDA workbench, which is an editor for metadata schema templates, but also so for compiling the schemas and for filling out the metadata forms. And we use for vocabulary building a tool pipeline developed by Nikola Vasiljevich, the FAIR Data Collective tools, to really build very quickly vocabulary that can be reused by these metadata schemas in the CEDA workbench. So altogether, it is then easy to produce FAIR metadata. So what should the vocabularies, how should the vocabularies be represented? They should be based on the World Wide Web specifications like RDF, which is a standard model for information interchange on the web, the Turtle, which is a human readable and very compact data format for storing the RDF data, or also discuss the simple knowledge organization system, which is used for representing thesauri, classification schemes, and taxonomies. So we are using ontologies and vocabulary thesauri for the options to fill in metadata in the templates. And in addition, for the observations, describing the observations, we use variables that are based on the IADOPT approach, which provides semantically enhanced variable descriptions, decomposing this in elements like the property and the entity observed. And these components are described also with vocabulary. So these variable descriptions based on vocabulary really also provide FAIR variables. And altogether, the data, the FAIR metadata and the FAIR variable approach will then really help us to provide at the end FAIR data. We see then that the community, the COVID-19 community funded by Zone MV breaks this traditional research cycle by introducing already at the beginning a series of training workshops to help data stewards to verify from the beginning on their data resources and their research outputs, so that at the end it is possible by help of templates built together with the community and FAIR metadata to link in the data with the metadata, make data interoperable and also reusable and linked to the published papers. We used, as I said, different tools like CEDA Workbench and vocabularies published in BioPortal. And here I show the whole process, how this has happened in the last 11 months. So we started to build metadata templates, but also vocabularies at the same time, together with the community, and deployed the vocabularies in BioPortal, and then linked the metadata templates with the vocabularies. And these templates then are filled out by the data stewards, created this metadata and served it so that this metadata can be reused in a web portal. And here you see the tools that we use for this. So the FAIR Data Collective with the Sheet2RDF tool to build the vocabularies, the OntoStack and BioPortal to serve the vocabularies. And in the CEDA environment, it is we can build these templates, the metadata templates, and link the metadata templates with the vocabulary entries. And this is also the environment that the data steward uses to fill in the forms then the metadata is served as RDF or JSON LD, which is then reused in the health research infrastructure website in the portal, which then at the end is able to semantically search over the metadata and present the research outputs in a linked data approach. So you can see these are the 10 metadata for machine workshops that that we use for Zone MV COVID-19 community M4M 7 to 17. And you can also see that the M4M 5 and 6 were dedicated to the wind energy community that will be presented later on by the colleague Sempre Viva after my talk. So the metadata for machine workshops were a good way to communicate and to work together with this community. And we organized this because there were 62 projects and more than 140 people involved at the end. We organized this in different workshop events with different domain fields like immunology or clinical studies or social studies, and we collected in the very beginning the information needed to build these templates. But the first session was always about introducing FAIR, setting the frame together with the community and brainstorm the building blocks and the vocabulary lists that we can use for this common portal. In the second session, then we build together this. So yeah, let's stop here and say how we did this. So we had this, I think, 5 different workshop events with different communities, the different projects, and then we had to consolidate what we found out from these first events, which in the second session then led to the CEDA template building, defining the different elements and refining the vocabulary list that we should use. We then continued in the third session on the terms level, vocabulary terms level, selected the terms with the community, and then we continued to define the terms that we selected, because vocabulary really needs to be defined and made also interoperable, so mapped to existing vocabularies. We then checked the quality of this vocabulary and created at the end the RDF vocabulary that is then reused in the CEDA templates. So it was a quite long process over the last months. This was the result. We built a project admin and a project content template, which is really community specific, defined by the needs of the Health RI portal. And for this, we needed also to build community-specific vocabulary. So we built a generic vocabulary that is reused in different templates here. And we provided a COVID-19 specific vocabulary that is mostly used in the project content template. And at the data level, we created templates based on the DCAT standards, or the catalog, the data set, and the data distribution level. We slightly extended the metadata elements from DCAT to our purpose. And we created for this also generic dataset vocabulary that we used here. And we also set the focus on the subject and the variable topic, which must be really community specific. So this is just two forms that I want to show you how they look like. So they are really human readable. It is easy to understand what data set should fill in. There are also pre-filled values that they can reuse. For example, for the funder information, in this case, it's zone MV, using the raw reference for zone MV. And here you see the project content form where we, for example, asked for the scope of the project, the used assets and the produced assets, and we asked what a project produces, data, samples or services. And for data, for example, we ask which type of data is relevant for the project. And you see here that in the drop down, you can choose from different terms that are derived by the vocabulary that we build together. At the bottom, you see more information about biomaterial that you can specify. This is just to give a brief insight how this looks like. So when people fill this out, they have a human readable filled out form, but at the end you get JSON LD, which is machine readable and can be exploited by a data portal. Here you see the products that we were able to produce in the last months. We have a guidelines document that really helps the data steward to go step by step through the whole process. We produced the project admin form and the project content form, the data catalog form, the data set form, and data distribution form. And here you see also links to in open view format where you don't need a CEDA account to see this. And you also see at the bottom the vocabularies that we could build together with the community. What is sure that these vocabularies are not final at all. I think vocabularies are never final in a final state, so they are always evolving over time. But what I could do together with the community is to start this process, to mean the first terms that they need to use or to understand each other and to describe their projects and data sets. But what is really lacking are lots of definitions that still have to be provided, lots of mappings to existing other vocabularies, but this will be done in the coming months, and I will help them to set up a vocabulary governance procedure to incrementally extend their vocabularies that can be reused in these templates. And at the very bottom, you see the website, and the website of FAIRi looks like that. So it uses semantic faceted search over the metadata provided on the project level, but soon we will also provide the metadata at the dataset level. So till end of September, the data stewards from more than 80 projects have provided the project metadata from these templates that we built together. But the other 40 will soon follow. So we will have more than 130 projects delivering metadata. And the next step is to deliver metadata on the dataset level so that also this can be exploited on the portal and queried across, so that projects or members of projects from one project can really understand and learn from other projects and research initiatives and reuse their data and knowledge. Thank you very much for your attention. If you have any questions, we will talk. I think at the end we will have time.
Yes, indeed. Thank you very much, Barbara. Yes, all questions will be answered towards the end after all presentations. And as I said, we should have plenty of time for discussions. So stay tuned for that. Now it is time for a short break. We will be reconvening in 5 minutes. So at 11 Central European Summer Time. So have a really nice short break and we'll see you soon. Okay, I suggest we start after the short break. Hopefully you were able to rest your legs for a while. So we have a few more presentations to go. The next one up is Robert Huber. He has been presenting, I guess, 2 times before at our FAIRification webinars. Really appreciate your effort with all the presentations here. So he's from Center for Marine Environmental Sciences at University of Bremen. So please, Robert, go ahead if you're ready. Hopefully you are back.
Yes,
there you are. Yes,
I'm ready, and thank you. I was just trying to. So here you should see my first slide. I hope this is also visible for for the groups. Thank you again for giving me the opportunity to present something here in this interesting series of FAIRification events. This time I will not mention Fuji at all, so I will be available in the question and answer round later on if a question on these tools will be raised. So today I will talk about geosciences and environmental sciences issues related to FAIR metadata, with a particular focus on Pangaea. This is the data archive I actually work on. So I would like to start with some a short introduction on Pangaea. So the Pangaea data publisher for Earth and environmental sciences is now available for more than 30 years. It was founded in 1993, but the history goes actually back a little further, where it started as a management system for cores, rock cores, and sediment samples, basically in the early 80s or mid 80s. The Pangaea is jointly managed by the Alfred Wegener Institute in Bremerhaven and the Marum Institute of the University of Bremen. This is where I work. The data which Pangaea hosts comes from a variety of sources. So I would say most of the data sets today come from submissions done by individual researchers, which submit their data sets using our ticket system and submission tool. what we also do is project management for research projects, European projects, national projects. We receive, of course, a lot of data from research centers. So both I just mentioned, the hosting institutions, but we have also agreements with other research centers like Björknes in Bergen and some others, which employ data curators, which are using Pangea's tool to upload data. We also have a lot of data delivered by research infrastructures, both national and international ones. For example, we have data from research infrastructure from the ESFRI roadmap, like EMSO or ICOS. Our focus is on marine and environmental data, but we also have, of course, terrestrial and non-environmental data. Pangea is certified as a long-term data archive. We are a member of the World Data System for several years now. We are accredited as a data management center from the World Meteorological Organization for radiation data. And we have received a data seal of approval, I think 1 or 2 years ago. So, some words on the data we host. It's very heterogeneous. For example, we have data which has been measured on what we call profiles. So these are measurements in the water column in ocean or seas, or measurements performed or counts and observations on sediment cores, ice cores, and also we host measurements performed in the atmosphere. We host a series of environmental time series. I mentioned these research infrastructures, which deliver, for example, long-term observations on distinct locations. We also have some multimedia data, annotated photographs, for example, movies and sound recordings, data on sediment samples. And what is gaining importance in Pangea is species occurrence data. I will explain this later on when we come to the metadata examples. And you see here the list is much longer on data types. Visit the Pangea website to see what we what we have. So in terms of coverage of our planet, you see this little pie chart here, which shows that most of our data now comes. Of course, I mentioned the marine focus from the hydrosphere, but we also have a lot of data from the biosphere and lithosphere and so on. So this is how a typical data set from Pangea looks like. So it should not be, sorry, the slide is destroyed. So you see in the background a typical metadata a page or landing page, which shows some metadata on the data set itself, title, and some more information on the measured variables and so on. Pangea is a very early adopter of the DOI persistent identifier system, and we label each data set with a DOI, and we also care for the proper linking using DOIs from associated literature to actually make it possible for the community and bibliometric services to link these data and information, data and publication information. In the foreground, you see a typical data page. So this is the typical data set what Pangea actually hosts. It's tabular data mostly, measurements which we brought into an internal ingest format, and which is the column labels here are based on the controlled list and ontologies, of course. So So just some numbers about Pangea. So we regard ourselves as integral part of science. We have supported more than 214 European and international projects since the 19th. This number of projects is a big, is larger actually, but these more than 200 are projects we have received funding and or other agreements. Data, I mentioned that, is highly heterogeneous, and Pangea now hosts more than 400,000 data sets comprising about 19 billion individual measurements or data items. The total volume of the data Pangea hosts is not that big, 3 petabytes, and we have an increase of about 5% per year in terms of data volume and number of data sets. Pangea has about 10,000 registered users, more than 10,000 actually, and well, we receive between 12 and 15,000 unique user visits per month using our system. Pangea is delivering its data and metadata to a variety of portals and consumers. So here are listed some, for example, we exchange data with publishers, but we also support some domain-specific portals or data providers like the Global Biodiversity Information Facility or the GEOS data portal, and some others. This is just an overview. We also, of course, provide the data to major search engines like Google and others. So now we go a little bit into the details, how we do this. This is an older illustration on the exchange formats and interfaces Pangea provides. So you can see here that we are, for example, offering XML-based metadata in ISO 1915 standard directory interchange format. That's an older one. And of course, Darwin Core and Dublin Core and schema.org, which is of course JSON-based. We use Open Archives Initiative's interface to deliver most of these standards, these XML standards at least, but of course we also provide a sitemap to well support search engines and some other formats. For example, for the biodiversity community, the Darwin Core, we now are using REST interfaces provided by GBIF. Prior to this, we implemented a Digier interface and so on. So this enables us to provide a really rather a slew of metadata formats, which we deliver to here a variety of portals. Some of them are older ones, which probably don't exist anymore, like this EOSC portal, which have been European projects setting up well, project-specific portals. Yeah, so I would like to also, because this was requested well, by our nice hosts, to well, say some words about specific metadata formats which can be used by basically my community, the environmental data community. So most important one, of course, is this ISO 1915 based, or the family of ISO 1915 based XML formats, which is part of a larger ecosystem, which is called the OGC SDI, the Spatial Data Infrastructure. And the purpose of this metadata format is to support exchange of geographically related information. So it's good for exchanging metadata on maps, remote sensing products, gridded data, but also the data types I mentioned in this Pangea slides, like a profile series of profiles, and also geotagged time series, of course. So this is quite good. There are also other formats which now enable this, but this is very often used in the community, and it's also supported by the industry. So, for example, ASFRI is contributing to the development of these standards a lot. The backside is that the standard is very complex, and there are several versions which allow you to encode XML now. So, for example, the 1939, which was the initial XML representation of the 1915. Today, there's also 1915.3, which are slightly different. And in addition to this, there are also community profiles, which enables individual community to, well, actually adopt or change this format a little bit to fit their requirements. For us in the European context, most important profile is the Inspire profile, which is a mandatory metadata format now for most governmental services, which has been put into national law actually in most cases. So these governmental agencies are, well, need to provide these standards. I mentioned the Open Archives Initiatives protocol, which is well suited to well, serve these standards, but actually, as you can see in this illustration here on the right side, the CI is also including services, and one of these services, which are basically the native exchange services for ISO, is the catalog service for the web, also the OGC standards, just to mention this. So this is how this looks like in Pangea. I was just thinking about showing this little snippet here, which shows actually just the encoding of a title, the date, identifier, and I think one author, including his email. So, but just to show how complex this metadata format is, it requires to use a lot of XML properties to, well, encode actually a comparably small amount of information. Oops. So what also is important in the environmental context is information related to organisms. So we support, I mentioned that this Darwin Core format, but there are also other ones which are well suited to express occurrence data, like the Darwin Core ABCD. And so common for these two standards is that it's not only for metadata, but these XML formats allow you actually to include the data itself, which in most cases in biodiversity, or the most basic one, is the latitude, longitude, and the name of the species which has been observed. Another option to provide this kind of data is now the Darwin Core Archive standard, which basically is a zip file which encloses Darwin Core metadata, or sorry, Darwin Core data, and it comes associated with an EML metadata XML file and another file which is also just indicating the content of the zip file. We switched to this recently because it's more appropriate for our needs. So, and regarding this EML, this abbreviation stands for Ecological Modeling Language. This is an XML format which is also well suited to express well, geographically encoded data, as well as data which is more specific to the environment. For example, it allows to specify taxonomic content, the species content, and so on. And again, of course, for environmental data, the ISO format is well suited as a metadata exchange format. Yeah, I mentioned that before. In Pangea, we now use Darwin Core Archive to exchange data and metadata with, for example, GBIF or OBIS. This is just an to be complete an example on how EML looks like, and in comparison to the ISO, you can see that a lot of much less XML envelope information is needed to encode metadata. So it's I would say a straightforward format which is well suited to exchange environmental information. I think that's my last slide. What I would also like to mention here in my talk is the possibility to use schema.org JSON-LD metadata for domain-specific purposes. And today, as far as I know, there are two major communities which are relevant for the environmental and earth science community. The first is the bioschemas community. I think the main driver of this community is the Elixir project, another large-scale European project or a cluster project. And it aims to provide life science-related schema.org types properties in order to adopt schema.org for domain-specific purposes. So what they reached, for example, is they proposed a series of types. This one illustrated here is the taxon type, which is for expressing species-related or species names and their ranks, for example, in schema.org. So this is, I think, a very good way. Another community is the ESIP community, is Earth Science Information Partners. They provide very, as well as generic, as well as domain-specific advice on how to use schema.org. This is very useful if you are looking for hints and so on how to use schema.org on the GitHub site. And so they also, of course, aim to support their community to use schema.org for earth science related data. In my point of view, this is a very interesting development. So people are using schema.org to serve actually two purposes. First purpose is to serve your own community, to exchange metadata in a way it is sufficient. And the other and second purpose is to provide schema.org to make your metadata visible in search engines. So it's also some kind of a search engine optimization process. Yeah, so this is the end of my talk. I thank you for your patience, and if you have questions on this or Fuji, I think I will be able to answer that in the question and answer round. Thank you.
Great, thank you very much, Robert. So now we have time for our next speaker, which is also the last one for today. We have Anna Maria Sempreviva from DTU, Technical University of Denmark. She's a coordinator of metadata and taxonomy creation. Please go ahead, Anna Maria. Sorry, Anna Maria, I can't hear you. Yes, now we hear you. Would you like to share your screen?
The screen, yeah.
Yes. Sorry, but we can hear you rather vaguely.
Yeah, and I was also thinking by myself. I mean, just
okay.
It's okay now.
It's in presenter mode. No, it's in. Yeah, you should. We can see all your slides. So if you can start the presentation mode.
Go to the second screen.
Yeah, it's in the very upper left corner from beginning. The symbol there, a little bit further down and to the left. Yes, perfect. Now we can see it perfectly. Thank you.
Okay, my presentation is a little bit different from the other presentations, and because I talk about the genesis of the metadata and taxonomies in our wind energy field. The wind energy field is a special field because there's a lot of component from the industry. So it's really data, sharing data, for instance, which was the purpose of this work, is still something which is very, they are touchy about this. But then, I mean, anyway, we try to do something about this, and then the presentation is find the data, metadata and taxonomies for fair data share use in wind energy. And I use this share use because it's actually the clue, sharing and reuse of data. So it's some kind of something that I invented. It's not, I mean, okay, the content is, I will give you the context about the work, which is the digital transformation of the wind energy sector. And I'll tell you about the stakeholders and within the open to fair transition and to instill in the sector this culture of sharing. Then I will tell you about the genesis of metadata and taxonomies in the wind energy and data portal that we kind of created or designed, and then the FAIRification process which is going on now. And then I will give a conclusive remarks. On the left, on the right, you see this poster. We got a prize in the Wind Energy Conference. It's our manifesto. It's open science sharing data tools and workflow strategy to inspire efficient collaboration. It is about distributed data. I'll tell you more about this. So the context is the digital transformation of the wind energy sector. It's a digitalization workflow. And you see here is this, can you see the pointer?
We can see the pointer.
No.
Can you see the pointer? Yes.
Yes, now we can see it. Yeah.
This is the workflow of digitalization, starting from data, digitization, going to new products and process and business model, innovation. And the goal is for the wind energy sector is to reach the leading renewable, to be the leading renewable in 2050 and contribute to the climate change and the climate problem, environmental problem, and so on. So we start from digitization, which gives a bunch of data. And this, as I think the Lego bricks show really what is the digitalization process. It's not only data, I mean, time series and so on, but it's everything. It's the process to move from analog to digital. And then you have different things there, different, I call it digital objects because it can be data, it can be workflows, it can be tools, it can be models. So, I mean, digital object is something that we use to be general. I don't want to move, we don't want to say all the time, this is data, this is a picture, you can say, generally speaking about digital objects, so everything we use in research to perform our research. And then, I mean, all this amount of data becomes big data. And the big data is defined as a multi-sector, multidisciplinary, multidimensional, with volume, velocity, variety, velocity. But in reality, big data is the edge of the big data moves with technology. Because big data in the 80s was something, was very, very few data. Big data now is something more complex. And then there is data management, and because we want to go from, one bunch of data to product. Then we have data management before starting data analytics, because data analytics needs a lot of data. And the data management can provide the data, but in this way, as they are now a bunch of undefined, unnamed data spread everywhere. There is no data management. So the problem in our sector is to there is a bottleneck in this workflow. The bottleneck is at data management level because data are not properly engineered and managed. So and this is a critical part because it's what we call the place where ideas meet data. If I have an idea and I cannot find the data, it's hard to, I have to find the data and then I have to produce data. So the process is slowed down. But if I organize the data and manage them, I can reach the data in a fast way. And then the process of digitalization, which is using data and digital technology to reach new products and process and business models, it's more fast. So we worked about, we've been saying, okay, we have to find a way to organize data. And the problem is that we have stakeholders like the data owners, which is mostly industry, and they demand control on data because this data is an asset. They want recognition, they want to protect the competitive advantage that the data give them. But they are willing, in a way, some industry, most industries willing to expose the data because they give visibility. And then there is, on the other side, the data user, which is kind of research institutions, perhaps, mostly, and which have to want to improve efficiency, want to save money, not to create data. If they have a data hand, will be more fast. They will not spend the money. So they are willing to sign NDAs, non-disclosure agreement, and then also they are willing to give rewards. So we have to put in contact these two stakeholders. And the keywords is visibility for the data owners, efficiency of the workflows, networking, control, recognition, and rewards. Then at the same time, now there is the funder, which can be the Horizontal 2020 European Commission, which is translate from open to fair. And the problem was that in 2014, open data was giving panic to people, to readers especially, because the open access of data was not really an option. But the fair data is a milestone in our sector because it changed the focus from availability to findability. And then, as before, Bert said, I mean, FAIR is not accessible data. FAIR is findable data. It doesn't mean that. And that is making more easy to transmit sharing culture to data owners. And also they say data as open as possible, as close as necessary. These are milestones for the sharing in our sector. So the issue is how to make data findable but safe. And the solution that we found is to create a searchable data catalog for distributed data, because data are distributed. Each organization has data, and this work has been thought about within the European Energy Research Alliance, joint program on wind energy, 50 plus European research organizations talking together, and where data is an important issue because it's the motor of the research. And part of these organizations were in a project which was called Integrated Research Program in Wind Energy. And this project started in 2014. It was a F7 project, but it was the last money, and then it started at the same time as Horizon 2020. So it didn't have actually the open science inside, and then we create a whole package for open data that became FAIR data. And in the era JP Wind, which is the short name of the European Energy Research Alliance, we wanted to make findable the digital objects. So as before also Barbara showed, each organization has data, and the problem is that distributed data is also inside each organization, because I have a data on my computer, and my neighbor has data in his computer, but do we know the data that we have in the section or in the department? Sometimes they are not organized, they are spread. So even in one organization, we don't find the data. And then if we have 50 plus organizations, then we have even more distributed digital objects. So we want to kind of offer document, because they don't have documentation attached. Then we want to document them with metadata. The principle is that without name, we will not call a person. I mean, if you call a person, if you have a lot of people, persons around you, and then you say a name, there will be many people that will answer, but you cannot really focus on one person. And this is the problem, the good thing of the naming data with metadata, because then you can assign, create a list of metadata, assign taxonomy names to the metadata, descriptive metadata, and then at the end to try to catalog this data in a portal. So from distributed data, which are not organized, then we can we can organize data for each organization and link them in a way through this metadata catalog. The principle is this, I mean, the search engine in a library in old times, I don't know, perhaps young people don't remember this, you got into a room and they open a drawer and there was a registry of books. And then there was a storage that you could look at with some indexes, which should be like a TOI. But then if you have a search engine, you can make a metadata catalog with harvesting the metadata for each organization. And then you can query the metadata catalog with tagging, with the terms that are vocabulary terms. And the more terms you use for searching, the more accurate is the search. So a user that would send a query will get say series of data sets, a list that can be answering to their goal. So the advantages of this system is the data owner has control. Data are visible without being accessible. You don't have upload data or not need of storage and data preservation centralized. And by applying filters, the user can accurately locate needed data. So we form a group of people and decide which metadata should be the metadata of the wind energy. You can see we use a Dublin core metadata element set for the general description. And then for the specific metadata, we use some non-Dublin core. These two actually are Dublin core. The subject is a taxonomy of the topics of the field of wind energy, and the taxonomy of the variables. And then this doubling core metadata as external condition, activity, instrument, model, and material. And this is actually what the applying this as a search with these terms, then you can find the data that you need. So these are tags for searching the data in a metadata catalog. And the good thing is that there are controlled vocabularies. So if the data owner tags the data with these terms, the data user will retrieve the data with the same term, using the same terms. So there is a correspondence between the two. And then we created the taxonomy of the wind energy topics with an expert listation. And then we have actually disseminate this taxonomy and metadata in different conferences. And everything started in 2017. Why the metadata and taxonomy are useful? Because then you can catalog workflow components, because this is a workflow for a project, preparation with data that you have to acquire data, and then you can go to analyzing data with scripts. They can be also cataloged, and the output can be cataloged, and then the notes can be cataloged, and writing reports and archives can be cataloged. So, and this in a workflow from data to dissemination will be faster if you have all these components at the end. And then you can do it only if you have this, you know where the components are. So we created this first ShareWind metadata catalog, which actually is a data registry. And this is the starting page where you can register your data. But, the data are tagged with the taxonomies and the metadata, the specific metadata from that we use for the wind energy. And each of them you define the taxonomy for each data sets. This ShareWind now is posed, and Nicola Vasiljevic, that you saw before, working with Barbara about the COVID, is working in verifying this metadata and taxonomies, and then we are doing a new registry, the SharePoint ShareWind 2.0. Conclusion.
Excuse me, Anna Maria, sorry for interrupting. We are running a bit behind, so if you could please wrap it up, I would be really thankful. Great.
This I just repeat what I said before. With this metadata catalog, we put in connection data owner and data user, and then I mean how they exchange the data is just the agreement. They can co-create whatever products. They can be exchanged for services, for money. It can be a marketplace. So there are different options that can be used. And this is the last slide. This is the current work of Nicola Vasiljevic. Is making the taxonomies machine actionable using fair data collected tools and workflows. And it's creating and exposing machine actionable metadata templates and their instances. There is a YouTube video about that. The metadata can be harvested and then developed in the ShareWind 2.0. then he can create rapid for metadata for machine workshops, as he has done successfully until now. Thank you for your attention.
Thank you very much, Anna Maria. So now we have run through all the presentations. Now it is time to address the questions. I don't know if you noticed, but I've also compiled all the questions and answers so far in a Google Doc for, yeah, I think it's a little bit easier to follow everything that's put into the chat this way. So if you would like to go to that document, maybe it's easier to follow, but I suggest we start from the very beginning. Barbara, she asked if the results of the repository level are being publicly available somewhere. And as you can see, Andreas has put a link to a Google Doc or a spreadsheet where we have compiled all the results in one. And then I hope that Volmar Nyberg Åkerström could specify what he means with the question, is there any uptake / potential adopters of the assessment tools / procedures at national level? Could you maybe specify? Thank you.
Yes, I can try to clarify a bit. So my understanding was that the solution and the results that was presented is kind of a proof of concept and something that's being done within the scope of the project that's ongoing. And I'm a bit curious on like what's going to happen next and where will this kind of be situated in the end. And I'm also thinking about that national efforts are being made to create catalogs of publications related to national universities. And I've heard some efforts around doing similar things for data sets, and that would be a good input, I assume, for this effort. I'm not sure that this is actually the case, and that's why I asked.
Yeah. Well, it's there are at least one or two EOSC projects that will basically adopt, as far as I understand, the setup that we have, the way that we have run the assessments in EOSC-Nordic. Of course, anyone is anyone could implement this for a national or local service if they wanted to systematically or regularly assess data sets. So yeah, I don't have like an answer to which projects that will sort of carry this on further, but as far as I know, I have provided at least information to at least one EOSC, I think it is EOSC Future project, which will adopt this. I don't know if that was answer to your question.
Yeah, I mean, at least I know it's going to go further, and then maybe as part of that, it will end up somewhere at the national level as well.
Yeah. So, I mean, the sample, of course, that we have used in EOSC-Nordic, that I don't know if that will be followed specifically further. That is a little bit up to the to NAIC as the sort of the coordinating organization of the EOSC-Nordic project, whether that there's a sustainable way to carry that on, but I think it will definitely be used in maybe a more European or international context.
Okay, thank you. So the next question, I think it has been answered. Correct me if I'm wrong. There has been quite a lot of correspondence from Richard Dennis about the Fuji tool, but I guess there was a note from Andrea saying that maybe Robert could address this question. So it's he asks, you mentioned using the Fuji tool to measure the FAIR uptake in data repositories with and without DataCite metadata. My question is the DataCite metadata schema version 4.3 enough metadata being collected to measure the data and datasets to determine that they are machine actionable? So either Andreas or Robert.
Yeah, I think the answer, I mean, the question has been answered. The last comment that I had to Robert here was somewhat separate. It was more general, whether he could just comment slightly, maybe towards the end, about how the Fuji tool assesses domain-specific metadata.
Yeah, maybe I can quickly just try to answer that. So Fuji basically uses three main paths to discover metadata. I think I explained that also during one of the earlier FAIRification events. So the first is it looks at the landing page, because Fuji starts with a DOI or a PID as a starting point, right? This in most cases resolves to a landing page. Then Fuji tries to identify embedded metadata there. For example, embedded Dublin core, JSON LD, microdata, RDFA. So these basically the main, the most often used ways how to express embedded metadata. In addition, Fuji tries to identify typed links, which are leading to metadata in files, well, XML files, for example, or JSON or RDF files. And Fuji is performing a content negotiation to discover XML, RDF, and some other formats. And based on this, Fuji can well, it tries to understand a variety of formats. So this is Dublin core, schema.org dataset, DataCite, schema, DCAD2, mods, mats, then domain-specific formats, which we have some initial support for, is DDI codebook, the ISO formats I just mentioned, and ecological modeling language. And of course, it tries to extract information, of course, from RDF graphs.
Okay, thank you. So the next question is also for you, Robert. It's from Karilahti. Just interested if the Fuji tool has any updates on PID detection. And then he refers to a link to the CTAF stable identifiers that has been used as PIDs by at least 14 big institutions holding huge amount of natural history collection species data that are not detected as PIDs by the Fuji tool.
Yes, CTAF identifiers are very problematic because there is no common syntax for them. So it is almost impossible to distinguish them from normal HTTP URIs. So this is why we have not incorporated any code to discover CTAF identifiers.
May I elaborate a bit my question?
Sure.
Yes, of course.
As I've posted this question already earlier, but I think we have a research infrastructure, FinBIF, and we have about currently 40 million occurrence records. We are using more than 100 million CTAF stable identifiers, including occurrence records, collections, datasets, taxonomy, vocabulary, schema, etc. So if you had to, for instance, update them to DOIs, it would not require only a huge amount of work, but it has a long price tag. And we are not alone in this situation. So that I would really like to think that there are ways to go over this, and it would be really fruitful if that would be, because as I said, it's not only us that are using them, and it's a huge community that are using the identifiers and still regarding them as PIDs, as we do still, and that would be very interesting to see whether Fuji tool could. Or if there are ways around to elaborate a bit with this. Thank you.
Yeah, as I said, it is very difficult because it is really not possible to distinguish CTAF identifiers from other HTTP URIs. I would recommend just to go back to the CTAF group and see how this can be done or aligned in a way that you, for example, can register these identifiers or identifier patterns at identifiers.org. So this is, I think, the place where a lot of stable identifiers from various groups are registered along with their syntax and or ways how to make it possible to distinguish in. And this is, my point of view, the zero cost version, if that's possible. But this would most probably require more efforts within the CTAF group. Yeah, it is problematic, and I was discussing this early with members of the group that the missing syntax of syntax identifiers is really problematic.
Okay, thank you. We have two more questions for Robert from Barbara. One, you already answered her in the chat, so it's around labeling, but I think that's solved in there. The next question is, measured variable in schema.org still does not help to disambiguate what is measured if people use their own variable descriptions. So after using all these community-specific standards, are you optimistic that the data is really findable and interoperable? Don't you think that making the variable description more precise, like the I-adopt approach, would help here?
Yes, the I-adopt approach is very important because it is actually an interesting way how to add ontology terms to measured variables, so which makes it much more easy to identify what has been measured. So yes, so that's definitely a way forward. Fuji, however, is very focused on an individual data set, and it tries to identify the measured variable and then verifies if this is actually delivered in the file which is or has been available, or if it has been available for download.
So this was more for Pangea. So
yes, Barbara, we are actually thinking about that, and you know that we are including terms or ontology term description now also in the JSON.org, and I think it will be interesting to actually use the I-adopt way to express terms there. So this is what we are going to do in the future.
Thank you.
Definitely.
Can I continue and ask directly? So I am also interested to use the Fuji tool together with the FIP approach. Do you know the FIP approach, the Fair Implementation Profile approach that I developed together with Eric Schultes? Because there we landscape the fair enabling resources that are not only data sets. And I'm wondering how good Fuji could help us to assess the fairness degree. And sorry, a question that I also wanted to ask is how much difference is between Fuji and the FAIR evaluator from Mark Wilkinson? How much is it? 80%, 70%? What is your added value of the Fuji? So I never understood this.
Yes, I really don't know the exact difference. Maybe Andreas knows more about that because he did a really in-depth evaluation of both tools.
Yeah, I can try to answer that at the very end, but yeah, we can just finish the questions first.
So are you interested to join this FIP combination Fuji initiative? Robert.
Yes, of course, every initiative which is using or evaluating Fuji is very welcome. We have currently submitted a proposal, which is hopefully a follow-up project for FAIR's FAIR, where other research artifacts or the fairness of other research artifacts is going to be an important issue. So therefore, I will be very happy if you can make links here.
And I'm going to answer the question of Volmer, which were the hurdles and opportunities. So my biggest hurdle was COVID time, everything online, working with so many people just via the screen. I would have liked to sit down with them in different rooms, work together, but somehow it worked. Yeah, I was confident that we could continue, but it was also not everything in the workshop time. It was also after the workshops with homework. Then lots of interaction that happened face to face, but virtually. I think it's possible to build something like that. There are opportunities to find common paths to express common needs and then develop the vocabulary for that. So I think it is needed. Otherwise, we never know what we want to communicate to others. We need to find common ways to express, to find common vocabularies for the metadata. I hope this was an answer.
Okay, and the very last minute, I will try to answer the question on the comparison between the Wilkinson assessment tool and the Fuji tool. So I should reserve that this answers the tests that we have made in the EOSC-Nordic project were done about 1 year ago. So we have, although we are still assessing using the Wilkinson tool, we are not updating the tool. So we are using the same version as from about 1 year ago. And I'm not sure if much has changed there, but the main reason why we changed to Fuji is transparency. So Fuji provides a much broader and richer output, feedback about what it is doing, what it is testing, and what it is finding in the data set. So that is a big that was a big reason for changing to Fuji, and also there are inconsistencies in the results. At least a year ago when we tested this, there were inconsistencies that we could not really which were harder than to sort of understand in the sense that there is less information provided by the Wilkinson tool. So yeah, transparency and richer output is the short answer to that for Fuji.
Thanks, Andreas.
If I may add to that, the tooling you saw, it runs both Wilkinson's evaluator as well as Fuji, as well as the Gopher Foundation evaluator. And essentially, Wilkinson's evaluator isn't as well. We actually didn't end up research on it, and the Fuji tool is built in a much better way. The Fuji tool, however, is static, so you can't really apply domain-specific conditions to it. The Gopher Foundation tool, on the other hand, is extremely well capable of adding domain-specific conditions. And both tools, as Andreas pointed out, give very good feedback on what you're doing wrong, whereas the Wilkinson tool is gives an internal feedback, which is very difficult to read and to understand. So I think these are the three tools, whereas Fuji is very good if you have a general data set for general FAIR scoring, but if you've got domain-specific conditions, the Gopher Evaluator tool system, we perceive is much better, much more flexible.
Okay, thank you, Bert, for making that clarification. I suggest we take one last question, although we are running a bit late, but still, hopefully you'll have time to answer this. Is a question by Volma for Barbara. What feedback would you give to an organization?
I already answered
something.
You
did already answer this one. Okay, that's great. Then we can move over to Bert for closing. Thank you.
Yeah, thank you very much. And thank you very much for being with us this morning. A particular thanks to the speakers, to the experts, of course. I trust that all of you have now had enough information also to see the relevance and the importance, of course, on fairness, and making sure that your repository is findable, accessible, interoperable, and reusable, and that also that you will understand better the importance and the relevance of these domain-specific metadata elements. I expect all of you either to take action yourself or maybe present some of these requirements in your organization to your superiors maybe, so that they will act on it. Okay, well, this was step number 4 in the process. If you need any help internally in order, for instance, to convince people within your teams, do not hesitate. You know where to find us, and we are more than happy to assist. Thank you again for being with us this morning. Sorry that we run a little bit late. I see that it's 4 minutes past 12. Still, that's not too bad, I think. So thanks very much again, and enjoy your lunch, and see you next time. Thank you very much.
Thank you, everyone, and especially speakers. Thanks.
Thank you all.
Thank you.
Thank you.
Bye.
Bye-bye.
Bye.